and try it again. So the session is being recorded. Okay, so let's go from there. But we're talking section 2.3 is on index families of sets. Okay, basically a family of sets is a set of sets are called a family or a collection of sets. Okay, we're going to extend the definitions of union and intersections, families of sets as opposed to sections. Do that. One set. I didn't do that. All right, so they give an example here. They said we would use the script letters A, capital A, capital B, C. And I'm going to use, because I have a difficult time doing these script A's and script B's on my computer, I'm going to probably use things like capital Greek letters, gamma, a delta, or omega for these sets instead of using the script. You'll see it. Here in the script A, we have 3 sets. I'm sorry, 4 sets. Let's set 1, 2, 3, and 4. All right, so that we can talk about the intersection of these sets. So we talk about the intersection of A would be what's in the intersection of all 4 of these sets, and the union would be what's in any one of these sets. So clearly, in this case, the union of these sets would be 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the intersection is what's in the overlap, what's in each one of the sets. So what's the intersection? Somebody say something so I can make sure you're there. What's the intersection of these?
Just 3. 5. Oh, great.
3, right? All numbers in all of them is 3. So
oh,
therefore,
yeah.
the intersection, I think I'm accidentally hitting something. Keep my, okay. The intersection of this, there we are, go again. Bear with me. All right. So the intersection of these sets. Again, you can do it not only here. This family of sets consists of 1, 2, 3, 4, but here we index it by the basic some positive integers. So you also have index sets like the complex numbers. I see Joshua's showing.
So
you have the index sets. Here the complex numbers. What was that?
When you do a union of a family of sets, so you're taking all the numbers that are in that family of sets.
In any one of them. Any one of them.
Okay, in one
whole set. Go ahead.
Okay.
So the unions is taking all the elements that's in any one of them. The intersection is going to be what's common to all of them. So if you look at the next set here the indexing set is the real numbers. Okay? It's a real number. So a real number greater than 0. So here the indexing set is an infinite set, namely all positive real numbers. And each one of the intervals in here, each one, this is an interval from -1 to 1. So it's all numbers from -x to x. It's all numbers between -x and x. For example, to give some sets in here. This is an interval. You have -1 to 1, -2, 2 to 2, and so on. You can have -pi to pi, any real number whatsoever. And clearly in this case, if you look at here, what's in the intersection of all these sets, if you think about it? What's the intersection between this set, -1, 1, and negative square root of 2 and 2? What's in the intersection? Those two sets.
Nothing.
-1 to 1? Yeah. Remember, negative square root of 2 to 2 is bigger. All right? So therefore, -1 to 1 is inside this one. It's also inside this one. So for these 3 sets, the intersection, if I just took these 3, it would be what? -1 to 1.
Oh, that's because it's an infinite family of open intervals.
Right. If I just took these 3 only, the union would be what? -5 to 5.
Mm-hmm.
Okay? But if you do all these sets, you can see what happens. I talk about the union of all of these sets as x goes to infinity. As x gets very large positive, what is this interval going to become? -infinity, infinity. So basically, this set here, if I take the union of all those sets, is going to be -infinity, infinity. And And the intersection is just going to be what? What's in the intersection of all of them?
Negative 1
What's
to
in the
1.
intersection?
Negative 1 to 1.
I mean, of all of them, now, for any x, x can be 1/2, x can be 1/3, x can be 1/4, x can be 1/5. So the only thing that's in the intersection of all of them is going to be what? 0.
Yeah.
0 has to be between, because you can keep taking x smaller and smaller and smaller. So the intersection, this is what they're going to say a little bit later on down on the page. But the union is defined as a set, again, just what you think. It's all those elements in the universe understood. So it belongs to one of the sets. Okay? Whereas, again, I like this definition here. So X belongs to the union if and only if, that's a double arrow, there exists some A. Notice we're changing into belonging to the family of sets A. Now, who could tell me what does it mean to say X does not belong to the union? What would it mean to say X does not belong to the union? This becomes what? There exists becomes what?
Wait, a disjoint?
What's the negation of there exists? What's denial of there exists?
Universal.
Yes, it could be what? For all A belonging to A, X what? What's the denial of X belongs to A? X does not belong to A.
For all X, there is no X that belongs to A.
Now it says, for all A belonging to this collection, X does not belong to A. That's the negation of that statement. The denial of the statement is, for all A belonging to A, X does not belong to A. And if X does not belong to A, X belongs to what? A complement. So that would be the denial of this. Okay, so to say X does not belong to A, belong to the union rather, would mean for all A in the collection, X belongs to the complement. And we're going to see that more as we go on. Now that's the union. Of course, when you define union, it can be thought of as we three sets. Everything is in any one of them. Okay, intersection is within the overlap of all three sets. And they give an example, and they mention what we said earlier. The set that we had up there originally for the set family was union was 1 to 10. And if you're given another set, here is B, beta rather. B is equal to the set here. We're using B, family of 2 sets. The union will be what's in any one of them, RKS. And where they have not talked about the intersection yet. And this one, of course, they show you that we did it by reasoning here. They did it by looking at a specific number and looking at the negative of absolute value minus 1 and the absolute value of y minus 1. Absolute value of y plus 1. That's not necessary. I just want you to be able to at least see why this should be negative infinity, all real numbers. Next page. So the intersection is defined the same way. I mean, except that now instead of saying, for all there exists, you say what? For all A in the collection of sets, X belongs to A. So it's in every one of the sets in the set. Again, who can tell me what the negation, what X does not belong to intersection?
It does belong.
Because it means there exists. For all becomes what? There exists A belong to the family. X does not belong to, or X belongs to a complement. All right. And they go on to say what we said earlier about the intersection of those sets. So we had up there earlier, the intersection was 3. And here the intersection turns out to be 0. We already figured that out. And of course, there are theorems that relates sets just as before. For every element X belonging to, for every set B in the family, B is in the family of sets, and the intersection of all of them certainly has to be in B. And this can be proven. And if you were to prove this, this would be a subset proof. How do you do a subset proof? Start out by saying, let X belongs, to the left side, and show that it belongs to the right side. Again, if for every set B in the family, the B is a subset of the union. Again, these are make sense. Okay, the family of set of the intersection is always a subset of the union. Again, these can be proven, but I think logically it makes sense. This is one we just mentioned, that the complement of the intersection, just like the Morgan's laws generalized, is the union of the complements. And the proof of it pretty much is exactly what we said earlier. And that was a missed typo in the book. Union of A, the complement of that, the intersection complements. Again, these are things that can be proven. Again, how would you, this is an equality proof, right? Right? You had to prove this one here. This is equality. So you show that if X belongs to the left side, and if and only if X belongs to the right. You can do it, and they do. I think they do an example of each one of these. Theorem 3.213 says, again, they don't prove these. I think they ask those exercises. We may do one of them. If A is a family of sets, then if B is a subset of A for all A belonging to A, then B is a subset of the intersection. And if A is a subset of B for all A belonging to A, then union of A is a subset of B. And they do a proof. I want you to look at the proof. Here we go. Look how quickly this proof goes. I'm going to ask you to do B. Proof A. Assume, notice how we start out. This is what kind of a proof? A subset proof. You assume the hypothesis, of course. Assume that B is a subset of A for all A belong to A. That's the same thing before. Assume the antecedent. Assume this. Then we suppose there's an element in B. That's exactly how we do a subset proof. Suppose X belongs to B. This is a subset proof. So then X belongs to A for all A belong to A. That's what it means. Okay? Suppose X belongs to B, and because B is a subset of the intersection, that means X belongs to A for all X, A belongs to A. Therefore, X belongs to the intersection. That's the definition of belonging to the intersection. How quickly that proof goes, and you can almost see how to do the next one, which I'm going to ask you to do. But it's a subset proof. You start out by assuming this. Suppose or let X belong to this union. Okay, and then you show that X belongs to B. Again, because every A is a subset of B. Excuse me. You can generalize this, okay? Oh, here we go again. You can generalize this to an index family of sets. You can generalize this to an index family of sets, as is the case at the bottom of the page. Same thing we were saying about this index family of sets. We can generalize it, call it delta. That's why I like to use delta to be a non-empty set, so that alpha is an element of delta. Alpha is the Greek letter, okay? Delta is the Greek capital. There's a corresponding set, ace of alpha. The family of sets is called ace of alpha, where alpha belongs to delta. This is an index family of sets. Delta is called the indexing set. Previously, we looked at the indexing set being maybe a finite set of positive numbers, or we looked at it being real numbers, but the indexing set can be any set whatsoever that we want to use. Okay, and again, they give an example of whether it's a perfect. I didn't put it on here, but it's in the textbook. And if you talk union of these sets, okay, union of alpha also sets in delta is going to be something in any one of them, and in intersections. Let's look at the exercises. Okay, they pairwise. Okay, they talk about disjoint, pairwise disjoint means that there's no overlap between any one of them. Let's come down to the exercises because that's what I asked you to do. Okay, the first one I think pretty much is what I have on the exercises for you to do in the text. I mean, in your practice exercise that I put on Blackboard. Let's look at B. How many sets are here? It's 4 sets. What's in the intersection of these sets? What's the intersection?
Which one are we looking at?
I'm looking at 1B. I'm looking at 1B. Above this.
Nothing?
No, so the empty set.
Yeah, this is your regular empty set.
All right. So the end, and so the union is going to be what?
Empty set.
Oh, the union. I'm talking
Ooh,
Oh, the
union of all of them
union.
is what?
Okay.
1 through 12?
1, 2, 3, 4,
Four.
Yeah.
1 through 12. It's
5,
all it's
6,
1 through
No,
12.
7, 8 is 1 through 12, right? All right. And look at the next one. It's 1 through 13, right? For B. Everybody agree? Yes.
Oh yeah. It's
Okay.
1 through
Look at the next one.
Yeah, 13.
Look at C. Now C is being indexed by the natural numbers. Okay? You're indexing it by the natural numbers. So no, when you have a situation like this, the first thing you should do is write down what is a sub 1. Right? Write down a sub 1. You should always have a pencil when you're in class, right? What is a sub 1 equal to? For C, 1C, what's a sub 1?
5. It's 5.
5 and what?
Then
6,
Is a sub
Then
1?
6.
7.
5, 6, stop, right?
Mm-hmm.
Oh,
It's just 5 and 6, correct? Everybody with me? A sub 1 is 5 and 6. What's a sub 2?
10.
10, 11, and
10,
12.
11, 12,
12.
right. 10, 11, and 12. What's a sub 3?
15.
16,
16, 17.
And
and
18.
what?
And 18.
18. Right. Are you with me?
18. Yeah.
So that's what you have to do is at least play around with some of the first ones and see what happens. And a sub 4, just for the fun of it, is going to be what? 20.
20, 21, 22, 24,
23.
and
24. Right? 20, 21, 22, 23, and 24. Because 6 times 4 is 24.
wait. So you for every iteration you increase
By
you
1
increase
from
the
the
size
first.
of the sets. Okay. So the first
Yeah.
one is 2 elements.
There's 2 elements, right?
How do you
Next.
how do you know that?
Because it says goes up to 6n. If n is equal to 1, 6 times 1 is 6.
So the first set is just 6.
It's going to be 5 times 1, then 5 times 1 plus 1, which is
Yeah,
6.
I know. Oh, okay, I see.
Are you with me now?
Okay.
Anybody else have a question? So therefore, the intersection of these sets is what? What's the intersection?
empty set again?
Yeah.
What's the intersection in C? What's the intersection of these sets that we just listed? A1, A2, A3, A4. What's in the intersection?
Oh.
Isn't it the empty set?
Yeah, I'd say empty set.
Empty set, of course. So the intersection of all these of A is going to be equal to the empty set, because there's no overlap even between A1 and A2. So you can stop. So the intersection. The union is a little bit more complicated to write down, right? But you know what's going on. You see the pattern. If you had to do the union of these, you would have what? 5, 6, comma, 10, 11, 12, comma, 15, 16, 17, 18, comma, dot, dot, dot. Because you see the pattern now. It starts basically at 5, 10, 15, 20, 25, 30, 30, okay, 35, 40, and so on. But we can't write them all down in a nice, neat package like this. I still be getting an idea here. Look at it. Let's play around with D. Okay, write down the first few sets in D. All right, now what's B sub 1 is going to be what? All natural numbers take away 1, right?
All natural
Are you
numbers.
with me? Take away 1.
Yeah.
Are you all looking at D? With the
Yes.
set D? B sub 1 is going to be all natural numbers take away 1 because n is equal to 1.
Okay.
What's B? So then what if you wrote it out as a set, it would be what? 2, 3, 4, 5,
Mhm.
6, so on.
And then B sub 2 would just be 3 starting.
If you take away 1 and 2, right, and you start with what? 3.
3, 3, 4, 5,
Or
and then 4, 5. Okay.
correct. And so you see the pattern? So B sub 3, B sub n is going to be 3 is going to be n take away the first 3, and so on.
So the union would be all natural numbers.
All natural numbers?
Oh, with no 1.
Right. All natural numbers. So essentially, it's going to be B1. The union is going to be B1. Are you with me? The union is just
Wait,
going
so
to be
how would it
B1.
go?
Mm-hmm.
How would it go?
I'm
if
sorry,
n
what was that?
1? How would it go if n was 1?
N is equal to 1, that means you do only 1. So n take away 1, because n is equal to 1. So the set would consist of only one element, namely 1. N minus take away the set element 1. So it starts with 2.
Okay, got you.
All right? And the intersection, okay, clearly the intersection of these is what?
It's empty, isn't it?
What was that? It's empty, right? Because n keeps marching up.
So the set will never share something.
Right. So it's not going to, the intersection has to be the empty set because you just can't, every time you think you've got something that's uh, in the overlap of all of them, certainly 2 is not, 3 is not, 4 is not, n is not, because you can start with n plus 1. So therefore the intersection has to be empty. But the union we got already. So we played around with those. Let's look at one with interval notation, because that's going to kind of ask you to do. Look at G. All right. And you do see G is a set consisting of A is A sub n equal to 0 to 1 over n. It's the interval. 0 to
Okay.
1 over n. So what's A sub 1?
0 and 1.
0 and 1.
0,
It says
1,
0 and
right.
1.
Yes. A sub 1 is 0, 1. Okay. Everybody with me? So what's
Mhm.
A sub 2?
0,
1 half.
1 half, and 1.
1 half. Okay, 0, 1
Oh,
half.
so it doesn't keep
It's
going.
0 to 1
Okay.
half. That's the interval. What's A sub 3?
0, 1/3.
Okay. Now, you continue like that. So what's going to be the union of all
0,
those sets?
0 to 1.
0 to 1. Correct. Because and all the rest of them are really inside of that one. So the union is just 0 to 1. And what's the intersection?
0.
Yeah, 0.
Yeah, it's just 0.
But notice that that's a parentheses. So is 0 in the interval?
Oh, so no.
No.
So
So what's
so
the intersection?
nothing.
The empty set.
Wait,
That's
so
what
if
we
it's
see.
if it's open parentheses, so an open interval, it doesn't count.
Right, you can't count the 0 because 0 is not in that interval.
Okay.
So it's numbers between 0 and 1 over n. So you can see in this case that the intersection is going to be the empty set. Because if you claim something is in there, you can always take an n value that's going to push it down below that number. Therefore, nothing is in the intersection because 0 is not even in there. Okay, that's good. I hope this is not the one I gave you for homework. That's all right. Look at K. All right. If we get K, I think we can do anything. All right. If you do K, I think you know how to do anyone I can throw it. Look at K. Here we have a sub n is equal to 1 over n to 2 plus 1 over n. That's square brackets. Where now we want n to be greater than or equal to 3. Right? I only hear from a couple of you, but I hope everybody else is on board with this. Are you looking at K? Let me actually underline, which we're here.
Yeah, I'm listening.
Yeah, me too.
This is the one we're looking. We're looking at this one right.
So a sub 1 would be
1/3.
1/3,
A sub,
and 2 and 1/3.
I'm sorry. I mean a sub. So you're really going to do a sub n. So a sub, but we have to start with n equal to 3. I'm sorry. So a
Yeah,
sub
so
3 would be 1/3 and
2 and 1/3.
2 1/3.
2 and 1/3, which is what?
6, 7/3.
7/3. Okay. All right. What's a sub 4?
A sub 4.
1/4 and 9/4.
Right. 1/4 and 9/4. Everybody with me?
Yes,
What's
sir.
a sub 5?
1/5 and 11/5.
11/5. Yeah.
Everybody got the pattern, right?
Mhm.
Yeah.
That's all you have to do. Once you figure out the pattern, then I think you're in business. Now, look at them. What's in the intersection, okay, of these? What's going to be in the intersection? What are we doing? Those of us, all we should have taken Calc 2. Is there anyone who hasn't taken Calc 2? Yes, you're taking Calc 2. You know how to find the limit as n goes to infinity of 1 over n. What's that equal to? What's
0.
the limit as n goes to infinity of 1 over n? 0.
Yeah.
What's the limit as n goes to infinity of 2 plus 1 over n?
Still
2. So it looks like it's going to be what?
2.
What you want to ask me? Ask for the union or the intersection. I think I said intersection.
Intersection.
All right. So, okay. So 1 over n. It started. I'm sorry. It started 1/3. Then went to 1/4, and it keeps going. So it looks like what's in the overlap is going to be what?
1/3 to 7/3.
1/3 to 7/3. Correct. Right? Because all the rest of them are going to stretch out beyond that. If you do this on the number line, you would see it expanding beyond that each one. Okay. No, I'm sorry, that's not right. Because what about 1/4? So it looks like it's not gonna be 1/3. What is you marching down to?
0.
0. Oh, I'm sorry. Lost. How did I do that?
What question are we on right now?
I'm trying to get back to it.
1K.
It skipped on me on its own. It's not coming back up. On K. We're on K.
Yeah, okay.
We're doing this one. All right. Now, what's in the intersection? Notice that 1/3, 1/4, 1/5 keeps marching down. So what's going to happen is that you're going to always have something that's a little bit bigger than what?
2.
And 0.
Oh yeah,
It
0.
looks like you're marching. It looks like it should be. It's not going to be. Is 0 ever included? Will we ever reach 0?
No.
No. So it looks like it's going to be all numbers a little bit bigger than 0.
Plus 2.
And it's going to stop at, you're right about the 7/3 part. So the intersection should be 0 to 7/3. I need to write that. Okay, let me just do the union. What should the union be?
The
Union should be what?
Uh, 1/3 to 7/3.
I'm sorry. Wait a minute, let me slow down here. You were right. Let me back up. Slow down here. Let's go back to the intersection. 1/4 is smaller than 1/3. You were right. You said 1/3 to 7/3. Is that what you said? Somebody said
Originally,
you were right.
but
My apologies. 1/3
no.
to 7/3 is correct. You're absolutely right. The union intersection is going to be 1/3 to 7/3. Please correct that, because 1/3, 1/4 is less than 1/3. So the intersection is going to be the one that you got from the first one. Each one of them, each one after that is going to be bigger. So 9/4. So you're moving away from the 7/3. So the intersection should have been square brackets 1/3 to 7/3. Please make that correction. It should be 1/3 to 7/3 for.
How did we determine that again?
Okay, let me just look at the board. All right. Can you see the board?
Yes.
Yeah.
We have 1/n to what was it? 1/n to 2 plus 1.
2 + 1.
Can you see that?
Yes.
Can you all see that?
Yes.
Okay. Now we're saying the first one was a sub 3 was 1/3 to 7/3.
Yes, sir.
So now on the number line, if you were to look at the 1/3 to 7/3, I'm not drawing it perfectly scale. We're getting this interval right here, 1/3 to 7/3.
Oh, I see. So everything
And the
after
next
that
one
would
is
be
what? So the next one is 1/4, right?
Mm-hmm.
1/4 to 9.
Hey, Joshua, can you mute your mic?
Was 1/4 to 9/4?
Yeah, I think 9/4 is less than 7/3 though, isn't it? Because it's 2 and 1/4.
Are we going down? Wait a minute. It's
Yeah, I
9/4.
think
I gotta get my math right here. It's 9/4. So this is what?
Yeah, the
2
top
and
end's actually
1/3.
decreasing too.
And the next one is 2. You're going the wrong way. You're asked. Let me get it
Yeah.
right. And
I
that's
was
why
wrong.
good thing I'm doing it on the board. So it should be 9/4. Let's get it right. The next one is what? 1/5. Right? To what? 11/5. You're absolutely right. It's marching down. So therefore, okay, as this marches on down, look at this part right here. I look at the limit as n goes to infinity of 2 plus 1/n. That's why it's good to work it out. Is equal to 2.
Mm-hmm.
Therefore, the answer for the intersection, let's get it right. The intersection of all these sets then should be what? 1/3 to 2. And is 2 ever going to be reached? No. Never going to reach 2. So the intersection should be 1/3 to 2. Please correct. Now we got it right. You see why it's important? I'm glad we drew the picture because that helped us to see it, right? So 1/3 to 2, because again, all these numbers are going to be a little bit bigger than 2. Okay? All these numbers are going to actually, well, we should include 2. Because all these numbers are a little bit bigger than 2. And we have 2 right there. We're going from 1/3 to 2 is going to give us the overlap. Now the union of all these should be what? Now, let's keep marching down. Again, you're going to get everything, this marching down to any number bigger than 0. So 0 is going to be at the lower. Notice we put parentheses, because it never reaches the value of 0. Okay? And what happens as n goes to infinity? The largest this can be on this side is when n is equal to 3. Right? The largest it can be is when it's 3. So it's going to be 7/3. And we include the 7/3. Now that's the correct answer. It should be, the union should be 0 to 7/3, and the intersection should be 1/3 to 2. We got it right now. I think by doing it as Okay, by doing it in terms of drawing the picture, it helps out tremendously.
It makes a lot more
Yes.
sense on the board.
Yeah,
Yep.
I'm suggesting you do the same thing. When you have to do any problems like this, always write out what ace of one, the first ones are. Write them out and look at this, get the pattern. If it's possible to draw a picture like this on the number line, do that. And that's going to be helpful in determining it. Even I was messing up until I did it on the number line. So, okay, so that's even more of a reason why we should be careful to do it on number line. Let me finish up for the day. We only got about 3 more minutes. I see that. Don't leave until I make sure I get everybody that's here. Got 13 of you all. Let me just call my roll again. Make sure I mark everybody present who's here. I got Hippolytus Bloomfield. Let me go back and see who's on here. Okay. I want to make sure I get my roll.
I'm here.
You're here, okay. I got Burris. Trey Burris. I still don't see Trey. Yes, I do. I see it. Okay. Mr. Savage. Savage.
Here.
Oh, you're here. Thank you.
Yes.
Mr. Thomas. Yes, I see you.
Here.
Wow. Travis Lee. Yes. You mean I got a full class today? I'm very impressed, gentlemen, that you all showed up. Let me just say what I want you to do again. I'll look at the assignment given you on Blackboard. There are 2 assignments now. One involves the proof. Do the best you can do with it. All right. You have questions about that? We'll talk about it on the next time. Other
And
exercise. What was that?
are the questions that's on the assessment the same ones on the 2.3 worksheet, or are they different?
Yeah, the assessment is going to be ones. They're different. Okay. They're similar, maybe some of the same ones, but do the 2.3 worksheet. I want you to submit those to me so I can get used to knowing how to look at your work on this during the assessment. It's important that you submit your test corrections. And those of you at this point, some of you did not. We don't have to work out how we're going to do it, but just do the test 2 corrections every. Are we communicating?
Yes, sir.
Everybody
sir.
do it by Friday. Everybody do the test 2 corrections by when?
Friday.
Friday. I will have office hours. I'm going to be here. What I'm going to do is probably leave your classroom open. So if somebody want to talk to me, I'm going to try to do it on, we got another way we can do this. And it's not where I roll. I can't think of it right now. But but right now, I'm going to probably leave the classroom open. So if somebody want to talk to me after class is over, stay on for a few minutes. I'll be here, okay? In the meantime, we'll finish for the day. All right. So if anybody needs to talk to me, about something, you can do it. Stay in class. Now I'll stay with you, but everybody else can leave. Work on the assignment. Work on your test 2 corrections. Try to get that ready by Friday. Look at the exercise that I've given. I've given 2 sets of exercises now. Called tests. They're not tests. They're practice exercises. Okay. All right. If anybody needs to talk to me, I'm going to be around for the next, for a little while. I believe I can hear you listen to individuals. Mr. Bloomfield, you there? Trevor Lee, did you get your test?
The take home.
Second test? No, the second. Did I send it to you?
I gotta
Your
check my
test.
email. I haven't.
Check it out because I sent it to you. Test 2.
Yeah.
You can use
I
that
don't.
use that to assist in doing the corrections.
Okay.
All right, and submit the corrections to me by Friday so I can just see how how this is going to work.
What if you didn't
Gabriel,
take test?
Yeah,
what I
Dr.
said.
Clark,
What did I just say?
I'm still in need
So
of
Go ahead.
I'm still in need of the second test too.
Did you get the test 2 corrections?
Yes, I saw that on Blackboard. So you just want me to do that?
Do it right now, okay?
Yes, sir.
We'll just talk about how we're going to handle it.
You got it.
Mr. Mathis, same thing. So you hanging with me, Mr. Trevor Lee? You got something else you want to ask me?
yeah. So you want me to do the corrections from my test, or do you want me to do the corrections that's on Blackboard?
It's the same thing.
Okay. So
I mean,
okay.
you don't have to, the problems you got completely right, you don't have to do. But I suggest you do it all just for practice. Okay? Do it all for practice. Jonathan?
I'm gonna talk to you.
Okay. Yes, sir.
Yeah. So my computer kind of went out a little bit when you was talking.
Okay, Jonathan, what I
So
want
you
you to do,
said
do test 2 corrections. Even though you haven't taken test 2, just do the test 2 corrections. And submit it to me, and we'll talk about how we can work with it, okay? Trying to see how to set up
all
to
right.
do individual tests on this Blackboard. I haven't figured it out yet, but we will. But for right now, just do the test 2 corrections like everybody else. And submit it to me.
All right.
Is that okay?
No problem. Yes,
Try
sir.
to get it to me by Friday, all right?
Got you.
All right. That's all you wanted?
All right.
I'll see you on Friday.
Yes, that's it.
See you on
See
Friday.
you Friday.
Hello,
Hey, how you
Dr.
doing?
Clark. Hey,
Yes.
yeah, I'm back. I definitely needed help like a review on the test retake. Cause I had a hard time for this one. I just want to make sure.
Okay. So what are you working
So
on?
I was looking at part 2. I just wanted to make sure. Did I get all that right? Correct? I don't know
I
if
mean,
you have.
I don't have, wait a minute. I do have your test. Hold on just a moment. I still do have your test, right? Copy them so I can have it with me. Yes, sir. Number 1 was right.
Oh, so for part 2, right? Did I get the whole thing correct? Or
Number
no?
2, number
Part
2, I
2.
took off 1 point because you said assume if n plus 1 is odd. Okay, it shouldn't be an
Okay.
if. I should have circled that if as well. Okay. If you're doing it by contraposition, you shouldn't be assuming if. Take the if out. You see it? But it says assume if n plus 1 is odd. It should be assume n plus 1 is odd.
Oh, so I don't need.
You don't want to do the then part because that's not, you're assuming the conclusion then. You want to show that. You want to assume n plus 1 is odd, and then you have to prove that n plus 1 is assume n plus 1 is odd, and to show that n is even. You don't write that down as a statement, okay? So the first
Okay.
statement of the proof should be assume n plus 1 is odd.
And you said it's odd, and you said and show.
Now assume n plus 1 is odd. That's your
That's
first
it.
statement. Mhm.
Okay.
You don't want to do the other part because if you say the other part, that's what you're trying to show. You're trying to show if n plus 1 is odd, then n is even. If you want to write that down, you need to put it as to show, colon, if n plus 1 is odd, then n is even. Then you start the proof by assume n plus 1 is odd. And everything else you did is
Okay.
correct. Okay?
Yeah. But what about number 3?
Number 3, again,
Yes,
you did
sir.
the same thing.
Okay.
Again,
So
you
it's
shouldn't
really
be doing
that's
this. You should be assuming what? You're proving, assume n is what? You
assume
see,
n is even.
right. You don't want to, what you're trying to prove is that if n is even, then n squared is, that's what you're going to show or you're to prove. But to
Okay.
start the proof, it should be assume n is even, period.
Okay. So is that the only thing I got wrong for that one
That
as
was
well?
it. That's right. Because I want you to not do that.
Okay. And the same goes for.
Same thing down for the next part. Assume n is odd. Okay,
Okay,
don't
I see.
assume n is odd, then n squared is even. Because if you do that, you're assuming your conclusion.
Yeah. Okay, I
You
see. I
made
see.
an algebraic mistake down there. You know that 2k plus 1 squared is not 4k squared plus 1.
Oh.
Bad algebra.
Oh, I don't know how I did that.
Yeah, I mean, you're taking a test. I mean, that can happen. But you see why it's bad algebra, right?
Yes, sir.
Okay. And then the
Uh,
last statement, you should say by contraposition. Therefore, okay, if n is even. I just want you to put that in there. And you need to finish up that part there. You didn't finish up that part. You did it by contraposition. You should say by contraposition that the original statement is true. It should, if n squared is even, then n is even. So you should make that statement
oh,
to
so
finish
you
out that.
instead of putting therefore, you want me to put by contraposition?
Yeah. No, I want you to say finish up that part you were doing. You're assuming n is odd. Then you show that n squared is odd. By
Oh,
contraposition, if n squared is even, then n is even. Because that's what you wanted to show.
okay.
Okay?
Okay.
And the last statement is fine. It's just that you should use a capital letter at the beginning of a sentence. And the
Okay.
last statement is perfectly all right. Okay. Now, like you really didn't know what you were doing on the next page.
Oh, that's good. All right, cool.
For number 3, on page 3,
Yeah.
You out in left field on here. Except for the last two, you got them right. Okay? But look, it says, for all x, there is some y. You have to tell me, given an x, what y value can you choose that's going to be less than x?
Okay.
That you should say, okay, given x, let y equal to what? What value, what number do you know is less than x?
Given x,
Let y equal to what? What number you know is less than x?
no number.
Yes, you do.
Negative. Negative x.
If I tell you, give you the number 2, what number you know is less than 2?
Negative 2.
Yeah. But if I give you the number 3, suppose I give you the number -2, what number is less than -2?
Less than negative 2?
Yeah.
Negative 3.
Right. How do you get to the -3 from the -2?
Minus 1.
Right. Given any x value, let y equal to what?
Let y equal to,
You just said it, 1 less.
1 less.
So
Okay.
y equal to x minus 1. Then y is less than x, because x minus 1 is always less than x. That's the end of the proof.
Okay.
Obvious.
So that's number 1,
Given
right?
x, let y equal to x minus 1, then y is less than x. Therefore, for all x, there is some y less than x.
So
Namely,
let
given x,
Oh.
let y equal to x minus 1.
so given x, let y equals x minus 1.
Right.
And
Then,
what else? And
then what? Y is less than x.
it's less than x.
Then you can write that statement. Thus, you can
Thus.
write that symbolically. For all x, there exists y. Just write the statement that's given. That's all there is to it.
Okay. Yeah. Also, I'm kind of having a hard time. You know how you sent me the test. It's kind of blurry. Some of them I'm having a sort of a hard time looking at it. But
You can't see
um,
what you put down. Let x equal to, you said let x equal to y squared. You mean it's blurred in terms of you can't see what the question is?
yeah, the question is, I can't see what the question is.
Sorry about that. But do you have, what about when you look at it on Blackboard?
Blackboard.
Yeah, these questions on Blackboard. Where it
I didn't.
says test 2 corrections.
Okay. Oh yeah, I can see it. I can see that. Yeah, I can see it there.
Okay, well that's the same. They should be the same question.
Okay.
Prove or give a counterexample.
Okay. So just to go back what you said for number 1. Well, for that particular part of the test, you said I should put let y equals x minus 1 and y is less than x. Thus, we write the question.
No, for all x, there exists y less than x.
So that's the
Given,
answer.
start out with, given x, where x is, of course, a real number. Let y equal to x minus 1. That's how you just proven that statement. You just proved it. You're saying that given any x value, I tell you how to find the y value so that you get the statement being true. Simple, but it is a proof.
Okay. Did you say I got the last 2 right?
Mm-hmm.
Okay.
You chose to give a counterexample. Let x equal to 1/2 Counterexample. One half squared, 1/4 is, so it's not, same thing here. There, you didn't give a number 3, 4, you just actually gave numbers that work. That's all you had to do.
Okay. What about
And
number
for number
2?
2, again, for all y. Now, tell me what y value you can choose so that x squared can never be less than it.
A value where x squared can never be less than it?
Right. Give me a y value that a square cannot be less than.
It's a positive 2?
X squared is
1?
always what? Positive.
Yeah,
Give me a y value that it can't be less than.
2.
X squared can't be less than 2. You want a y value so that it's not true.
Uh,
That y equal to what?
the negative number? What did I
Yeah,
put? Okay. Negative number.
yeah, or 0.
0.
X squared can't be less than 0.
Nope.
It can't. Watch it. If you, well, 0 it could be. It can't be less than. It has to be equal. So that's 0 would work. That's a counterexample. That y
Okay.
equals to 0. Then there is no x. So that x squared is less than 0. Hence that statement is a counterexample.
Okay. So okay. So in this case, I'm gonna let y equals 0.
Correct.
Let I don't. Would I let x equal something or no?
No, because the fact is that it says there exists an x. So x squared less than y. You let y equal 0. There is no x. So that x squared is less than 0. Hence, you give an counterexample. The statement is not true. That's a counterexample.
Okay. All right.
That's it. Next page. Well, you know what the truth is.
So did you say literally let y equals 0? Then I'm done, or just
Let-
have to put
Then you have to say, you have to make a statement. Let y equal to 0, then there is no x belonging to the real number such that x squared is less than 0.
along to the real number.
So that's a counterexample to that statement.
You said there's no x belong to the real number.
Yeah, such that
That's
x
such
squared
that
is less than 0.
such that x squared equals 0 is less than.
Less than 0.
I'm sorry, you keep cutting out every time.
X
Say that
squared
one
is
more
less
time.
than 0.
Okay. Is less. Thank you. Well,
You got a dog? What was that? You there? Uh-oh, we lost you.
sorry, that was my mom. She was laughing. I'm
She was
sorry.
laughing. Why is she picking at you? Why is she picking at you?
Nah, she was watching something. I'm sorry.
Okay. Now look at, why did you miss number 1 on part 3? I don't get that. You missed class or something?
Let me see. Part 3. Yeah, I might have. Yeah, it was yeah. I don't know. It was a hectic week. I don't know. I think those few days. Well, yeah, that day I think I missed class.
No,
Well, I came to class, but like I was worried. Yeah, sorry.
I thought that was an easy 10 points. But you
Yeah,
know what
no.
to do now, right? Complement of A is everything that's not in A.
Oh,
So A complement is everything that's not in A. You get
everything not
what?
in it.
2, yeah, 2, 4, 5, 7, 8, 9. That's what A complement is.
Okay,
A complement
everything.
that's not in A. That's in the universe that's not in A. You got it?
Yes, sir.
Then you got an intersection that would be.
You said intersection.
Yeah, that's what it says. A complement intersect B.
Okay, how would I write something like that though? Not an
A
A.
complement is a set equals, A complement equal like a set. 2, 4, 5,
2.
7. All right. Set consisting of 2, 4, 5,
Okay.
8, 9, right?
Okay. 7.
Now you
You
find
said
that's what A complement is.
okay. All right.
You got it?
Yes, sir.
Now you find out what's the intersection with B. What's the overlap?
Um. Intersection.
So what's in common?
6.
You
6.
just said 2. What about 2, 4? What's in common to both A complement and B?
Oh. 2, 4, 5, 6. Wait. 2, 4, 5. Yeah. 2, 4, 5, 6. Right? Don't you
6 is
intersect?
not in. 6 is not in. 6 is not in A complement.
Oh, 2, 4, 5.
That's the answer.
Oh, everything not okay. All right. Okay. Cool. Okay. I see.
This class cost you on that one. The
Yeah,
next
I
one
really
should
did.
A intersect C. Find what's in overlap of A and C. Union that what's in complement of A. You should have it.
The same thing. Just do B. Wait.
I'll leave it to you to figure that one out.
Okay. Okay.
Now you know the answers to number 2.
Yes, sir.
Opposite of what you have. But you need to
Mm,
make sure you understand why.
okay.
Remember, the set consisting of the empty set is not the same as the empty set. A
Yes, sir.
consisting of the empty set has an element in it. Empty set has nothing in it. So those two are not the same. Now if you think about that, you'll get this right. Last page. You certainly didn't know what you were doing over here.
No, I didn't.
I think I gave you some credit for 3. I was being nice.
Okay.
Okay. You really should construct a counterexample. You should do more than what you did. Okay, let me see if I can let me put okay. I may not be able to do it. Okay. Are you able to see the whiteboard? Can
Yeah,
you see the
yes,
whiteboard?
sir. Yes,
Okay.
sir.
But what you should be doing here is that you should be drawing those overlapping circles. All right. I'm trying to draw them. I may not do a great job here. This will be okay. Let me just. Um, I'm trying to draw those overlapping circles. I'm not. I'm trying to do it, but you come up with it better. The idea is that you're supposed to have a circle, and you're supposed to have another circle that's overlapping with it. Okay.
Okay.
And another third circle that's supposed to be overlapping. Intersection of those is Can't do it very good. Okay, now I'll tell you what I'm gonna do. I'm practicing. Okay, you're supposed to kind of draw a circle. All right, you draw another circle, just like you had it, and then you draw the other third circle. And you're supposed to put numbers in each one of those. Then you have the big box, the universe. Then you have the
Okay.
universe around it, like this. And you're supposed to put a number in each one of these. Okay? You're supposed to be able to number that 1, and you number this one is 2. Okay. Number each one of these regions. Put a 3 in there. Okay, that's supposed to be a 4 here. And you put a 5, 6, 7. Okay, I'm sorry. Usually we put the 1 on the inside.
Okay.
We usually put 1, 2, 3, 4, 5, 6, 7, and usually we label it outside as 8. Okay. Now, and you can write down what A intersect B union C is in terms of those numbers. Okay. Am I making? Let me just. You're supposed to be able to write down what it is in terms of. Let me try it again. In terms of those numbers, I am not very good at it. Wait a minute, can you see the? I tell you what. Can you see the? Let me just put the board up.
Yeah, the board worked. The board
Okay,
really
let
worked.
me do it on the board. You saw the board before, right? Okay,
Yes, sir.
Let me do it on the. Let me show you my picture there. You see the board?
Yes, sir.
Okay. So here's what. Yes. So you're gonna have the universe. Then you have the overlapping circle. This is circle A, B, and C. You number each one of these regions. 1, 2, 3, 4, 5, 6, 7, and 8 for the universe. So if you let U be the set consisting of 1, 2, 3, 4, 5, 7, 8. All right? So then when you start doing, if you do the A intersect C, A intersect B union C, A intersect B union C on one side, and then you do A intersect B union C, A intersect B union C on the other side. Do it in terms of these numbers. So what's in the set A? 1, 2, 3, 4, I'm sorry, 1, 2, 4, 5. So here is 1, 2, 4, and 5. Intersect that with what's in B union C. B union C is 2, 3, 4, 5, 6, 7. This is 2, 3, 4, 5, 6, and 7. When you do the overlap of these two, what do you get? You just got the 2, 4, and the 5, right? This comes out to be equal to 2, 4, and 5. And you do the on the other side, A intersect B, that's an overlap of 8. Overlap is 2 and 5. So this is going to be 2, 5. Union that with C, C is 4, 5, 6, and 7. So this is 4, 5, 6, and 7. And when you union these two on this side, you get 2, 4, 6, 7. And notice that these two are not equal to each other. Okay?
Okay, I see.
That's the counterexample. This shows that these two are not equal to each other. Because this set comes out to be 2, 4, 5. This is 2, 4, 5, 4, 6, and 7. See how to do it? That's
Yes,
what
sir.
I
Thank
expect.
you.
That's what I wanted you to do on that problem.
Okay.
See, since you missed that day, I didn't get it, right?
Yeah,
And the last, you certainly didn't know what to do, correct?
you're right.
Uh, you missed that day. This is what we call a subset proof. All right.
Okay.
So
Okay.
you got this. Let me see. Can I erase this? You got it? You
Oh
see?
no, no sir, no sir. Do you do that for both? You do that. So is that the full answer for that
That's the
particular
answer.
question?
Number three. This is number three. Oh,
Okay. Oh wait.
number four is something different.
Okay. Let me just copy that real quick. I was trying to
Okay.
listen.
All right.
It's getting kind of blurry too. I don't. It was just clear. I don't know what happened.
Is it on your end or my end? I just turned the light on, but I don't
I
want to
don't
make
know.
it worse.
It might be. Okay. I think I can see it.
Can you make it out?
Yes, sir.
Believe me, next week I'm gonna be able to get me I'm trying to get me a stylus so
Okay.
I can write it on the computer. But right now I have to make it with this. Main thing
You
is
said
all those open.
you said under B union C that's 2, 3, 4, 5, 6, 7.
Yeah. 2, 3, 4, 5, 6, and 7. That's what B 2, 3, 4, 5. Yes, that's what's in
And
the union of B and C.
intersect is 2,
Just
4,
2, 4,
5.
2, 4, and 5 intersect.
Okay. Now I need to do the other side.
Other side is A intersect B is 2 and 5. A intersect B is 2 and 5.
4, 5, 6, 7.
Yeah, 4, 5, 6, 7 is what's in C.
2, 6.
So if you do the union of these two, you get 2, 4. Oh, I'm sorry, I left out the 5. It should be a 5 here. 2, 4, 5, 6, 7. Sorry about that. Should be a 5. 2, 4, 5, 6. And this one is 2, 4, 5. Again, you can see which one is a subset of the other. But that wasn't a problem. Got it?
I got it. Thank you.
Okay, now the other one, the last one, again, if you missed those classes, you missed a lot in terms of how to do a subset proof, but you need to know how to do it. That's something I'm going to ask you to do again, all right?
Yes, sir.
So you definitely need to know how to do this last problem. It's going to come up. In fact, you're doing something like this for homework. Okay, this one says if A intersect B is equal to B.
Hey, I can't see anymore.
You can't see it. Oh, wait a minute. Did I lose you? Wait a minute. Did I cut it? I think I turned it off. Oh, they're the classes. Can you see me now?
No.
you
Yeah.
see me
Now
now?
yes, sir. I can see.
Okay, it must kick me out because they think the class is supposed to be over. If A intersect B is equal to A, then A is a subset of B. Right? This is
Yep.
what you're supposed to prove. And the first thing you should write, assume this. You would have got 2 points if you just said that. Assume what? A intersect B is equal to A. That's how you start. Assume the antecedent.
Okay.
Are you with me?
Yes,
Next
sir.
step. This is now a subset proof. How do I know it's a subset proof? Ignore that.
Mm-hmm.
You start a subset proof by supposing an element is in the left-hand side. X belongs to A. That's the next line. Suppose X belongs to A.
Okay.
Now we use this fact. A is the same as A intersect B. Because A intersect B is equal to A, what must be the case? X belongs to A intersect B.
Okay.
But if X belongs to A intersect B, what does that mean? That's what? X belongs to A and X belongs to B. Hence, X belongs to B. What you wanted to show? That if X is in A, X is in B. We've
Okay.
shown. We started with suppose it's in A, and that's in B.
Okay.
We've shown, and we've shown that A is a subset. In the proof, therefore, if A intersect B is equal to A, then A is a subset of B in the proof. You're going to get a
Okay.
but make sure that you know how to do this for the future. Okay?
Yes, sir.
So if I put the same problem on the final exam, you're going to
Okay.
get it right. Correct?
Yes, sir. Yes, sir.
That's what it's all about.
All right. Thank you.
Any other questions?
Well, I guess I have a question on. I'm just trying to make sure my structure and how I approach this class is better than this
Okay.
last time. But so for the next class, will we be on 2.4?
We're finishing up 2.3. I'm hoping if I do, I'm hoping to get started on 2.4 this Friday, but we're gonna have to finish up, make sure everybody can do everything for 2.3. Okay?
Okay. So
Everybody join in with us today, and I want to make sure everybody get that test two corrections done.
okay. So you want us to do the test corrections, the practice problems. Do you want us to do those problems on the page as well?
Yes.
Make sure to do all that.
Do them and submit. And if you can submit it to me, that would help me to see what you're doing. It's not going to be graded, but
Okay.
if you do what you can do and submit it to me, but hopefully before we meet on Friday, that way I can get a chance to get some feedback on whether you all are getting what I'm doing. Okay.
Okay.
It's
I mean, I
quicker-
can say,
It's not for graded purposes.
okay. I think I'm gonna be able to get probably. I'm gonna be able to get both of the practice problems done. The practice homeworks.
That's
I'm
what
gonna
you
have a
should
hard.
do.
I'm gonna have a hard time sending you the page because I don't have a computer right now, and I had to copy. I have to screenshot and put the picture on. I have to do all these particular things I can't do right now because I don't have the tech. But I will have that soon, so I can show
I'm getting
you.
me some new stuff. Here, so I know everybody's working on. That's what this week is kind of our transition week. So I want everybody to do what they can do to see what you need to get. So that by next week, hopefully the ball will be rolling. I'm
Mhm.
not excited about doing that production, so I can make sure that everybody is on board.
Yes, sir. Well, thank you.
That's the kind of subject that I don't want to do until I make sure we get everybody, on board with us. Okay.
Okay. Thank you.
All right, Mr. Birds, we look forward to seeing you on Friday.
I see you. Have a
I'll
good
make
one. Be
sure-
safe.
Perfect.
Be safe, sir.
You do the same.
Thank you.
Bye bye.